Hello students, today's agenda is to check your homework. We're going to be writing the explicit formula, and you will be able to do 7.3. The explicit formula is going to be specifically related to arithmetic sequences. So today students will be able to find the explicit formula for arithmetic sequences. And so let's start with a scenario. It says, let's consider the following problem. You have $3 on the first day. You have $7 on the second day. You have $11 on the third day. You have $15 on the fourth day, and so on. How much money will you have in the 1,235th day? Let me say that again, 1,235th day. So yesterday we learned, or we reviewed about the recursive formula where you had f of 1, which is the initial point, and then f of n, meaning that you go back to the previous one, and you had to always go back to the next one. So that means that to figure out this day, you would have to do the process 1,234 times to be able to figure out how much you will have in the day 1,235. However, today we will learn about explicit formula, and we'll get there in a minute. So, what are we looking at in here? Okay, what do you have? What do you start with? Well, the first time you have $3. The second day you have $7, $11, $15, and so on. And what does this come from? If we were to make a table and put days in here and money in here, meaning the input and the output, day 1 you have $3. Day 2 you have $7. And what does that $7 come from? What's going on each day? Well, it seems that I have the $3 from the beginning and 4 more the next day. For day 3 I have $11. This means that I had 3 the first day, I added 4 the second day, and I added 4 the third day. So 3 plus 4 is 7, plus 4 is 11. On the fourth day, I had $15, that's what it says in here. This means that it's 3 plus 4 plus 4 plus 4. And so, looking at this pattern, I can say that if I put n, well, we'll go to n in a minute. So this means that I have my 3 plus 4, how many times? 1 time. In here I have 3 plus 4, how many times am I adding 4? 2 times. 2 times 4 equals 8, plus 3, 11. In here, I have the 3 from the first day, and I'm adding 4. How many of those days am I adding 4? 3 days, okay? So right now, if you can notice a pattern, I have the initial point, right? The initial point. And then I'm adding 4, I'm adding 4, I'm adding 4, just like in the recursive formula, I'm adding 4, and then I'm multiplying the addition of that 4, but how does it compare to the day? So day number 2, I add 1 4. Day number 3, I add 2 4s. Now, day number 4, I add 3 4s. Day number 3, 2 4s. Day number 2, 1 4. So on day number n, I don't know what this represents, how many 4s am I adding? Well, it's 1 less than the number of days. If this is the number of days, that means that I'm going to have my initial point plus the pattern, meaning I'm adding 4. But how many times am I adding 4? Well, the number of days minus 1. Okay, and so that's how the function will be written. Okay, now in here you see that it doesn't have f. It doesn't have f. So this doesn't refer to a function. It just means that you're going to multiply the pattern times n minus 1. In here we can definitely do distributive property. And then we start simplifying. F of n is equals to 3. Positive 4 times n is plus 4n. Positive 4 minus 1 is negative 4. We combine like terms and we get f of n is equals to 4n. 3 minus 4, negative 1. So my explicit formula will allow me to go directly to that 1235th day without having to go back to the previous number, and I'll show you in a minute finding that for that one day. Okay, so the explicit formula can be written like this without being simplified, or this is the simplified form of the explicit formula. Either one is correct. Okay, so I can use either this one or this one. I'm going to do it with both actually. Oops. This is the simplified. So I'm going to do it with both so that you can see that you will get the same answer for the 1235th day. Okay, so let's figure that now that we have the explicit formula. Let's find out how much money we will have on day 1235th. Okay, so that means that I'm gonna use this one first, the one that is not simplified. F of 1235 is equals to 3, which is the initial point, right? The initial point plus 4, 1235 minus 1. Remember that we always had 1 4 less, okay? And so that's equals to the initial point plus 4 multiplied by 1234, okay? For day 4, you multiply by 3. For day 3, you multiply by 2. For day 2, you multiply by 1. So for day 1235, you're going to multiply by 1234 times, okay? 1 less than the number of days. And so this is going to be 3 plus 4 times 4 is 16, carry 1. 4 times 3 is 12, and 1 is 13, carry 1. 4 times 2 is 8, and 1, 9, and 4 times 1 is 4, okay? Remember that we do PEMDAS, so multiplication comes before addition. That's why we did that part first. And then we add the 3 plus the 4,936, so that's going to give me $4,939. So after 1,235 days, I will have this much money if I save $4 each day. Okay, again, the reason for which we have 1 less in here is because the first day we don't add that 4. Okay, let's look in here. that first day, this is day 1, you don't have a 4 included. Only until the second day you have a 4 included. The third day you have a 4 included, but on the first day you don't. So that's why we don't have, or we have 1 less. Okay, 1 less in here. Okay, now let's use the explicit formula in simplified form. So it's going to be f of 1235 equals 4 multiplied by 1235 minus 1 equals 4 times 5 is 20, carry 2. 4 times 3 is 12, and 2 is 14. Carry 1. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4, minus 1, that's equals to 4,939. So if you notice, whether you simplify or not the explicit formula, you will end up with the same result. So let's see. I know it looks like it's a lot of process, but today's lesson is just to write the explicit formula for arithmetic sequences. This is just to show you why is it that we have to subtract 1, but for the next examples, all you have to do is you get the sequence, you write the explicit formula. Okay, so let's look at the first example. So in here you have 5, 8, 11, 14, 17, 20, 23. What is, well, he says we have 2 parts, and that's the initial point and what we're going up by. So the initial point is 5. And what is what we're going up by? So it looks like we're adding 3, but we have to check to make sure that that's what's happening. Yep, we're adding 3, so plus 3, plus 3, plus 3, plus 3, plus 3, etc. So we're adding 3, that's my pattern. So we can say that we're going up by 3. This is called a common difference. Okay, let me write that in here. The pattern is also called a common difference. So let me write the initial point. We said that it was 5, and the common difference is adding 3. So for my function, you will see how easy it is. Again, you don't have to figure out for day 2000 or day 1,000,000. Right now, what we want is that if you're given the sequence, all you have to do is write the explicit formula. And the explicit formula is always f of n equals initial point, pattern. I call this also the pattern, okay? Also called the pattern or the rule. So the rule or pattern or common difference is adding 3. And remember that we add that 3 every day except the first day. And that's why we always put n minus 1, because we added the 3, but that 3 is added in here, not in here, and in here, and in here. So 1, 2, 3, etc. Okay, so again, this was my initial point. It goes right here. My pattern is to add 3 to that first one, then add 3 to the previous one, add 3 to the previous one, etc., etc. Okay, and so that goes in here, and the pattern or common difference always multiplied by n minus 1. Okay, always as a factor with the pattern. Okay, let's try another one. So it seems that at the beginning it starts as if it was very difficult, but then you can see that it's not that hard. This is another example. And so again, we always will need The initial point, before I continue with this one, I just want to remind you that the reason to find the explicit formula is because with this one we can go directly. You notice that we were able to find day 1235 without having to go to the previous one and to the previous one and to the previous one. Yesterday with the recursive formula, you cannot find day number 6 if you don't have number 5. You cannot find number 8 if you don't have number 7. So the recursive formula works for small numbers or a small list of terms. And the explicit formula works when you need to find a number that is far away from now, like day 2000 or day, 99. You don't want to repeat the same process with the recursive formula 98 times before you get to 99. So you can use the explicit formula, okay? Okay, so the initial point in here is 20. And what is happening? Well, I'm subtracting 2. The next one, I'm subtracting 2. I'm subtracting 2. I'm subtracting 2. Minus 2. And so I can write in here that the initial point is 20. The common difference is I'm subtracting 2. And so my explicit function is going to be f of n, all the time f of n, initial point, common difference, and we're going to put n minus 1 as a factor right next to the pattern or common difference. Okay, that's all you have to do for today. Just find the explicit formula. And again, with this explicit formula, I can figure out how many or how much money I will have, or debt in this case, I will have on day 36, directly without having to do 35 processes, okay? Or day 50, or day 100. Okay, let's see. I want you to try, maybe pause the video and try these 3, okay? And I'm going to give you the answers already, but I want you to pause it so that you can take a minute to do them on your own. But I'm giving you the answers now, so pause it. Here are the answers. I'll explain them briefly. So, this is the initial point. You're adding 2, and then minus 1. For this one, you have the initial point, you're subtracting 2, and n minus 1. For the third one, you start with negative 4, and I know this seems tricky because of the signs, but you're adding 2. You have a debt of 4, then you add 2, and now your debt is smaller. You add 2, you finish with your debt, you add 2, now you have positive money, and then you add 2. So the pattern is to add 2 and minus 1. Okay? Now let's go the other way around. But you know what? I think I want to explain this one a little bit more. Just because sometimes we get a little bit confused with positives and negatives. Sorry about the scale is not very properly. So if you start at 4 and then the next one is a 2, going to the right means adding 2, right? So that's why the pattern is to add 2. And then you are at negative 2. To get to 0, you're adding 2. Positive 1, positive 2. So you're adding 2. And then from 0 to 2, you're adding 2. I think that one's easier to see. From 2 to 4, you're adding 2. Okay? So I hope you can see that better. Only you were having trouble. Some of you don't have trouble. Okay, let me see. Now, Now let's go the other way. Find the first 5 terms. Now you're given the explicit formula and you're going to find the list of terms. Okay, so let's see. If we have f of n equals 4 plus 3n, since we don't have n minus 1 in here, like in the examples that we did, that means that we don't have, see, in here we have initial point, the pattern or common difference, multiplied by n minus 1. However, this is simplified. And so, we don't have the initial point in here. We're going to have to actually figure out f of 1. We're going to replace f of 1, then f of 2, then f of 3 to find the first 3 terms. And from there you can really see the pattern. So f of 1 is going to be 4 plus 3 times 1. And the reason for which we're replacing by 1 is because we're looking for the first term. So this is going to be 4 plus 3 times 1 is 3. That's 7. So that's my first term. Now we have f of 2 for the second term. And so it's going to be 4 plus 3 times 2. Because we're looking for the second term. It's going to be 4 plus 3 times 2 is 6. Okay, we multiply 3 times 2 is 6. We bring down the 4, and 4 plus 6 is 10. That's my second term. We do one more. So we do f of 3 equals 4 plus 3 times, we're looking now for third term. So it's going to be 4 plus 3 times 3 is 9. Equals 4 plus 9 is 13. And you can continue to do f of 4, f of 5, or f of 6. However, you can actually see that this is going to be my initial point and that I'm adding 3 each time. I'm adding 3. So I can add 3 and get the next term, which is going to be 16. Plus 3, the next term is going to be 19. And it says to look for only 5 terms, but you can definitely go on and on and on. Okay? So now, again, I'm given the explicit formula. All I have to do is plug in 1, 2, and 3 to find the first 3 terms and then go on from there. Okay, let's do the second example. For the second one, again, my formula is f of n equals negative 2 minus 5 times n minus 1. In here, I have the n minus 1, which is part of the explicit formula. That definitely shows me that this is going to be my initial point and that this is going to be my common difference or pattern. So, you can definitely do f of 1, f of 2, f of 3, or you can just say, oh, my first term is going to be negative 2. And for the second term, all I have to do is subtract 5 from that. So it's going to be negative 7. And I subtract 5 from that, which is negative 12. Subtract 5 from that, which is negative 17. Subtract 5 from that, which is negative 22. Again, this is only because I already have n of 1, which shows me initial point, pattern. Initial point, meaning the first number, and what I do to that number. Okay? Now, some people, again, get confused with the negatives. So if you don't get confused with the negatives, you're ready to go and work on 7.3. But if you get confused with the negatives, this is what it means. Okay? You are a negative 2, and then you subtract 5, meaning go back 1, 2, 3, 4, 5. That's negative 7. It's not positive, it's negative 7. And then again, subtract 5. It means, again, 1, 2, 3, 4, 5. That's negative 12. Again, 1, 2, 3, 4, 5, that's negative 17, etc., etc. Okay, you go about 5 more to the negatives, you're at negative 22. Okay, so these you can find when you have n minus 1 as part of the formula. You immediately see the initial point and the pattern, but some people don't feel comfortable and they want to see, oh, I want to do with the work, okay? I want to do f of 1, f of 2, f of 3. That's perfectly fine. So it's negative 2 minus 5 times 1 minus 1, which is negative 2 minus 5 times 0. Negative 2 minus 5 times 0 is 0, and so that's negative 2. That's my first term, okay? So in my first term, I'm going to put negative 2. Then I go to f of 2 equals negative 2 minus 5. I put n again as 2 minus 1. Negative 2 minus 5 times 2 minus 1 is 1. Negative 2. And then negative 5 times 1 is negative 5. Which means negative 2 minus 5 is negative 7. Okay, that's my second term. Then I go f of 3 is equals to negative 2. I'm going to use part of that other paper. Minus 5 times 3 minus 1. And so that's negative 2 minus 5 times 3 minus 1 is 2. Equals negative 2. Negative 5 times 2 is negative 10. And so negative 2 and negative 10, that means negative 12. So that's my third term. And so in here I see the pattern that I'm subtracting 5. So it's going to be negative 17, negative 22. Okay, that's only if you want to do this process, because when there is n minus 1, you can just go directly with this, okay? Or if you want to do the long process, that's fine. When you don't have n minus 1, then in here you definitely need to do f of 1, f of 2, f of 3, okay? Because you don't have the n minus 1, so you cannot see the initial point and you cannot see the pattern in here, okay? Okay, so now have fun doing 7.3 and until the next video.